This is RD Sharma Solution Class 12, Chapter 19. We are taking exercise 19.30 of indefinite integrals. Now in this question, the concept I explained you earlier, the order of the numerator and denominator are same. They have the same order, which is 3. In this case, we need to get the order of the numerator lower than the order of the denominator. So for that we need a division. We need to divide it. So this is how we divide. So we want x cube. For that we need to multiply it by 1. So it will be x cube and this plus x will come here. Now we need to subtract. This subtract means x cube minus 1 minus x cube plus x. So this gets cancelled. I'll show you here. X cube minus 1 minus x cube minus x. X cube gets cancelled. You will get negative 1 and minus x. So it's basically negative 1 plus x. So how do we write this? The same integral which I am talking about, it can be written in this form. So let's go along with this negative 1 plus x. I'm taking negative outside, 1 plus x remain like this. So we have x cube plus x in the denominator. Now this can be done easily. If you call it as I, we have to integrate this first and this is the second part. So the first integration is x. Please remember, because I'm going to add it later. And this I1 I'm going to do, or we are going to do just now. For that, this 1 plus x divided by x cube plus x. This x cube plus x in this, the denominator, you can take x common, you'll get x square plus 1. So x into x square plus 1 you'll get. Now when we have the order 1 in the denominator, we take a, constant a. X square plus 1 is bx plus c. And this is, denominator will be x square plus 1. Now let's cross multiply. A multiplied by x square plus 1 and here x divided by x multiplied by bx plus c. In the denominator it will be x into x square plus 1. Here you have 1 plus x divided by x into x square plus 1. You can cancel these two in the denominator. So let's multiply. 1 plus x equals to ax square plus a plus bx square plus cx. Now take the similar terms and combine them. A plus b x square, then we have cx, and then we have capital A. Now we'll equate the similar terms. That is the coefficient we are going to equate in order to get the constant values, which we have used as a, b, c. Now on the left, there is no x square, alright. So 1 plus x is there, but x square term is not there. So a plus b equals to 0, c will be equal to, we have an x term there. So c became 1 and a is 1. Now a is 1, therefore b will be equal to negative 1 because b is equal to negative a. B become equal to negative 1, a is equal to 1 and c is equal to 1. We'll put it here. Now when we put it here and then we can integrate it easily. So I'm going to write this just now. So we are talking about I1. Integration of dxx is already done. This I1 is the second part. So integration of 1 by x, because we have transformed this integration, the second part into this one. 1 divided by x plus 1 minus x by x square plus 1. You can just divide this and separate these two terms, 1 by x square plus 1 and negative x by x square plus 1. We are going to integrate them separately and we have done it quite a number of times. So you are well aware of that. 1 by x is directly log modulus of x. This can be 1 by 1 plus x square. You can write it as 1 by 1 square plus x square. That means integration of 1 by a square plus x square. And all these will be changed into negative because initially x was there, then minus integration of I1. That means all these terms are going to be changing sign. But for now, 1 by a square plus x square is tan inverse x by a. In this case, x is x and a is 1. So we have tan inverse x. How about this one? See, this we have done, I think, 100 number of times. So half log modulus of x square plus 1. This is a direct result. I hope that you are quite well versed with it. So x minus this whole term which we just got. So now I'm going to change all the signs here and combine it with x in order to get the final result. So x minus log modulus of x plus half, I'm taking it in front, half log modulus of x square plus 1 and minus tan inverse x. One is missing, you can just add it. Now how this is going to be written, that's very important. You have to start from here, you have to divide and then followed by all the instructions which I provided you, you can get this result. All the English things you can write. X square plus x plus 1 divided by x plus 1 whole square x plus 2. Now this is quite clear to you because we are on the 45th question. This kind of question we have already done. So I'll just tell you how to make this as a fraction or partial fraction, a divided by x plus 1, b divided by x plus 1 whole squared, and then we have this x plus 2, so you can just have a c here. Now just integrate this, you already know, because there are two terms with just linear equations, one with x plus 1 whole square, you already know negative 1 by x plus 1 will come for that integration. So this is how this can be done. It's very straightforward. I hope you'll be able to do it. This is the reference you can follow. 1 by x multiplied by x raised 4 plus 1. Now there are a few questions which are going to be in front of you, and those questions will follow this scheme. So you need to understand this question very carefully. X raised 4, you always tend to notice the highest power, and you should, because we need to do something across or around this x raised 4. If you differentiate this x raised 4, 4x cube will come. That's why x cube and x cube I have multiplied in the numerator and denominator. Now what is the advantage? When we take t equals to x raised 4, or you can take t as 1 plus x raised 4, whichever way you like, because in both the cases the result is going to be the same. So it's better that if you take t equals to x raised 4, you can just avoid this, but you can take that also, it's up to you. When you differentiate dt by dx, 4x cube will come. So dt by 4 has become x cube dx, and since we have multiplied x cube in the numerator as well as the denominator, x cube dx can be directly represented by dt by 4. And in the denominator you have x raised 4, because x cube into x is x raised 4, and 1 plus x raised 4 is 1 plus t. And as I just indicated, x raised 4 can be written as t minus 1, or you can write it as this x raised 4 plus 1, t plus 1 also you can write. Both the ways the same result is going to come. So the main idea is to find the partial fraction of 1 by t, t plus 1. So a by t plus b divided by t plus 1. So just cross multiply a multiplied by t plus 1 plus b multiplied by t divided by t into t plus 1. Here 1 by t, t plus 1. So just cancel this out. At plus a plus bt, this becomes equals to 1. So you can take this t common, a plus b will come, and then a will come. So 1 on the left. So from here directly a becomes equal to 1, and a plus b will become equal to 0. When you put a equals to 1, b will be equal to negative 1. So you'll get 1 by t minus 1 by t plus 1. Now I'm integrating. We can do it in one screen only, so don't worry. Log modulus of t minus log modulus of t plus 1 will come. And you already know that log a minus log b. Let me write it. Log a minus log b is log a divided by b. Log a plus log b is log a into b. Log a minus log b is log a divided by b. So this will become log t divided by t plus 1. 1 by 4 is already there. But if you remember, what was t previously taken? So I'm writing the final answer right now. I becomes equals to 1 by 4. Here you have log t x raised 4, x to the power 4. So this will be x raised 4 divided by 1 plus x raised 4 plus constant of integration. This whole is your final answer. Now this is how you're going to write it, because once you know the logic, all these English things we have, putting, all this can be added. Logic is important. Why we multiply numerator denominator by x cube? If you understand that, then I hope and I wish that this question and questions which are related to this question will be very clear to you. 1 by x cube plus 8. Now again, you will be tempted to multiply this numerator denominator by some number. See, 1 by x was there, we just formed a by x. 1 by x plus 1 whole square. What did we form out of this? I'm just saying how to form the partial fractions. For that we wrote a divided by x plus 1 followed by b divided by x plus 1 whole square. This already has been indicated to you. When you have a quadratic equation in the denominator, say ax square plus bx plus c form, then you will write bx plus c divided by that particular quadratic equation. In this case I'm giving you an example of x square plus 1. Now this is just for example, but here we have x cube. When you have x square plus 1, you have, see, linear equation in the denominator, constant in the numerator. Quadratic equation in the denominator, bx plus c form. But when we have a equation with 3 power, that is a polynomial here, because order has increased, it has become 3 now. So this x cube plus 8 will be written like this. It will be a divided by x. This is quite clear to you because this is a linear equation. X is a linear equation. In x cube, what will be the power above? It will has to be square. 1 power lower than what is in the denominator. So you don't have to write bx plus c, you have to write bx square plus cx plus d. You have to have a quadratic equation over this x cube plus 8. This is very important. This is the whole core of this problem. Alright, now already you know how to go about it. Multiply, cross multiply, take the LCM of these two terms. A into x cube plus 8 plus x into bx square plus cx plus d. In the denominator you can have x into x cube plus 8. There is x also, I have not written, just assume that x is there. Now you can just cancel these two out in the denominator. So multiply the numerator first, ax cube plus 8a plus bx cube plus cx square plus dx. So I'm combining these terms. I'm not writing x into x cube plus 8 in the denominator just now. I'm just showing you that I'm combining these two terms in order to get these similar terms which can be equated to the left side. And on the left, it is just 1 on the left. Then we have cx square, then dx, and then 8a. So on the left, if you check, only 1 will be there because x cube plus 8 into x definitely is going to be cancelled. Now a plus b becomes 0, c becomes 0, d becomes 0. Only 8a will be equal to 1. Why? Because there is only constant term on the left hand side which is actually 1. So a became 1 by 8, b became negative 1 by 8 because a plus b equal to 0, c is 0, d equal to 0. So in place of a we are going to write 1 by 8. These became 0, only b has come which is negative 1 by 8. So let me put negative here 1 by 8. I'm not doing it right now, I'm just showing you where I'm going to replace all these in the actual integration which is following just now. So the integration will become something like this. 1 by 8 integration of dx divided by x negative 1 by 8 for b, and then integration of x cube plus 8 in the denominator and dx in the numerator. The first term you are quite clear about it. 1 by 8 log modulus of x. Now you'll ask the question dx divided by x cube plus 8. How we are going to do that? Now x cube plus 8. We have to concentrate on x cube. See, 8 can also be written as 2 cube. But d by dx of x cube is what? It's 3x square. So if you take x cube as t, dt by dx will be equal to 3x square. So you need a 3x square actually. 3x square dx will be dt. So if you want a 3 here, 3x square, this is dt. If you assume x cube to be t, this will come. You can write this dt. If you remember, bx square negative 1 by 8, x square was already there. I didn't write it. It was already there. I just missed it to show you actually. That was in my mind, but I didn't show you. Remember, x cube was already there with negative 1 by 8. So this 3x square dx can be written as dt by t. X cube plus 8 was taken as t. Log modulus t will come. Log x cube will come. And one more thing you can do. You can take x cube plus 8 as t. See, in order to make this, I'm just showing you. There are multiple ways which are possible. X cube, you can take t. But if you take x cube plus 8, then this 8 will be eliminated. You don't have to do anything with that. Otherwise, x cube equals to t, so you have to deal with 1 by t plus 8. That will be a problem. So x cube plus 8 has to be taken as t. 3x square will come automatically in the numerator. With the dx it will become dt, and then log x cube plus 8 will come. So let me write it very clearly because there are certain things which I explained you. 1 by 8 log modulus of x minus 1 by 24. Log modulus of x cube plus 8 plus constant of integration. This is your final result. And this is how it has to be done. It's a quite simple question, but this is a new kind of question. X cube plus 8, how to deal with this? This is quite clear to you. This question is very easy. A divided by 1 minus x you will do. And then bx plus c divided by 1 plus x square you will do. Because 1 plus x square is actually indeed a quadratic equation. 1 minus x is a linear equation. That's why we had a on it. So there is nothing special in this question and you can do it. Now this question has trigonometry involved, but it's an easy question, but I'll do it so that we recall all those things. We'll do it later. Thank you so much.